All right, our next round of level 1, level 2 are going to be with adding and subtracting. In order to add and subtract, adding and subtracting is always very picky. So what you need to have is make sure you have exactly identical innies. And then once you do, what you will actually add are just the outies. So number 13, my identical innies will just come along and I will subtract the outies of 5 take away 4 for 1. On number 14, the check marks of 8 will just go along and then I'll add the outies. Now, if you happen to notice that you could take this one and factor it down, or simplify it, I should say, I'm sorry, this would be a better answer, but this is okay as well. So what makes level two problems is you want to turn your level 2 problems into level 1 problems. So 3 squared root of 6, I really can't do much with, but 24, I can break it down into factors. And now my innies will just go along for the ride. And I will actually just subtract the outies. And number 16, 8 square root of 3, I can't do anything with, but 2 I could break down into this, and the 4, square root of 4 can become a 2, and then I'll just drop the other one down, and now my identical innies will come along for the ride, and I'll just add the outies and get 12. All right, last part, complex numbers. There is not a level 1 or level 2. You will be expected to do all these problems. So in our first section, which this actually should have been first, you need to remember that when you take the square root of -1, it is worth I. So 21, what I would do is break it down into something I can take the square root of. And the square root of 64 is 8, and now the square root of -1 is I, and I get 21. On 22, I can take 36 or -36 and break it down into this. The square root of 36 is 6. The square root of -1 is I. And then I can multiply those, I guess, outies together. And that's my answer for 22. 23 and 24 won't be quite as simple, but what I can do is break this up into 4 and 6 and -1. The square root of 4 becomes a 2. The square root of -1 becomes an I. And then I can multiply all those outies together and bring along the square root of 6. And on to just breaking it down into the factors that are perfect. And then I can multiply my outies. And there you go. On 17 and 18, we are going to be adding and subtracting. Please don't confuse this, especially my students, with neighbors meet the neighbors. These are neighbors meet the neighbors because they're right next to each other. 17 and 18, we are just adding and subtracting like terms. So I'm actually going to start with 18. Whatever I like to do when I have to combine like terms is stack it up and down instead of left to right. And I'll just stack my like terms with my like terms. I'm going to put a 1 in front of that I. So when I go for my 5s, they actually cancel out. And when I add the i's, I get 3i. And then that's it. On 17, I think most of us do better with addition. So I want to turn this subtraction into addition. I'd rather add these complex numbers than subtract them. But if I change this into its opposite, so not subtracting but adding, then I'm going to have to go to the stuff behind it and change those as well. And I want to look at this first thing as a -2, and the opposite of that is a +2. And then I want to look at this as a -5i, and the opposite of that is a +5i. And now what I'll do is, again, stack my like terms. This will be an addition problem now. And now when I add the real number portion, I get 7. When I add the imaginary number portion, I get 3i, and I have a new complex number. The last two, 19 and 20, you need to remember here that I squared is worth -1. So I call this the neighbors meet the neighbors because they are all very close to each other. So I just got to have everybody meet. So 2 meets 3, I get a 6. 2 meets -3i, I get a -6i. And now 2i will go meet everybody, and I like to stack my like terms as I do this. And when I multiply or have the last neighbors meet, the 2 and the -3 give me a -6. There's a lot of 6's here. But the I and the I give me I squared. So what I can do is start to, let's double check this, 6, -6. Okay, these will actually cancel out. And then what I talk to my students about here is that this -6, that I squared will turn into a -1. So what I just circled will actually just become a 6, a positive 6. And then what ends up happening is these 6's are like terms, and I can add them and get 12 for my final answer. So when I do 20 and I have neighbor meet neighbor, I'll get 6i, and then I'll get 8 along with I squared. But this with the I squared really is 8. It's supposed to be an 8 times a -1, because remember I squared is worth -1. And so this can now turn into a -8, and there's my final answer. So that is your ICANN 11. Make sure you have this when you go to class.